Test doubles are objects that replace the real classes or methods. They are useful in cases where you want to isolate the parts that you are testing from the rest of the application. In this short tutorial, I will explain where and how to use different types of test doubles. I will demonstrate how to better isolate the parts being tested. I will also give examples of how to get visibility on processes that are otherwise hard to verify. The application that we're testing imports phone calls placed by customers so that we may bill them for the excess usage. The tests will focus on importing the call records. Let's begin. The class that we're unit testing has a method called importFromCSV. It reads a file, parses it, saves the parsed records, and returns them. It relies on a database class to save the parsed records. The problem with it is that we need to instantiate it with all of its own dependencies. Also, calls to our method here will slow down the tests, force us to clean up the database after, overlap with its own test suite, and overall be a nightmare to maintain. It also relies on parseCSV line present within the same class. This one will also break isolation, requiring possible dependencies, overlapping with tests, and cause maintenance pain when you decide to change its implementation. Here is the parseCSV line that I just mentioned. It takes a string line and converts it to an array. It checks that the customer exists before proceeding. It then creates a call class with the minutes calculated based on the start and end times. This calls another method called isExistingCustomer, so you can see how the chain of dependencies can get very long and potentially require a very heavy test setup. Note that the return type here ensures that if anything else than a call instance is returned by the method, PHP will fail with a type error, so you won't need to write a test to assert that. Hey, fewer tests! Let's view this dependency chain on a diagram. Import from CSV depends on an instance of database. That database can in turn have its own dependencies in the constructor. The database saveRecords method can also be calling other methods. Import from CSV also depends on parseCSV line. That method itself depends on isExistingCustomer, which in turn can depend on something else. When we are testing import from CSV, that method is considered the primary method. Everything that is directly linked to it is a collaborator. Not only will you need to create a huge setup in order to test it, but you'll also need to change your test whenever any of the dependencies down the line change. For example, what happens when isExistingCustomer is later modified to call another method, getAllCustomers? To keep your tests manageable and future-proof, it is imperative to cut the dependency chain by mocking out the directly linked collaborators. Say we're unit testing parseCSV line. To isolate this primary method from its collaborators, we bypass the existing implementation of isExistingCustomer. We can make it return a can response in our test. This way, the dependency chain is severed and our method is perfectly isolated from outside interference. This is the essence of mocking. We'll write a unit test for the parseCSV line method, in which we want to ensure that a 5-minute gap between the start and end dates in the CSV yields the correct number of minutes. We set up the stub. Since we're mixing real and stub methods in one object, we create a PHPUnit mock and exclude the method for which we're writing the test. We use method isExistingCustomer will return true to explicitly set the can response that we want from this method during the execution of this test. The method must be present in the callImporter class, but its implementation does not matter. It could be empty at this point. The next step is to set up the data for our test. parseCSV line only requires a string representing the CSV, so this is what we'll create here. The first column is the customer ID. The second is a start at 9 o'clock, and the last column is an end of call at 9:05. Now we set up the expectations. This test serves to prove that the call duration in minutes is calculated correctly. This is the step in which we exercise the method, meaning that we call the method with the data that we set up. The variable actual record will contain an object of type call. Finally, we verify that the calculated minutes match our expectation. Let's look at the other types of test doubles. A mock serves a different purpose. Where stubs help us verify state at the end of a test, mocks help us verify behavior. This will become clear in the next example. Of course, mocks provide all the same advantages as any test double, like isolation and deferred implementation. Now, a dummy is typically used to quickly fill parameter lists. Often it doesn't even get called and is simply there because an interface forced the method to require it. This is useful if they in turn have a complex list of parameters, so you can break the dependency chain and set up fewer objects for your tests. Here's how we'll use the dummy and mock. The primary method is responsible for reading a file and returning an array of phone calls that the customer made. The parsing of each line is delegated to its collaborator. We already tested that lines are correctly parsed by that method, so no need to do it again. We can, however, make sure that this method has been called twice to keep an eye on performance, for example. If it's called more times because some nested loops aren't properly set up, then the test will fail. This verification will be achieved by using a mock. The second collaborator is the database. It is required by a primary method. Since we won't be verifying anything on the database in this test, we'll use a dummy. Back in our test class, we'll create another test for the import from CSV method. We want to call it using a 2-line CSV file and ensure that the collaborating method is called twice. First, we set up the mock. Same as in the previous example, we only keep the real implementation of the method being tested. The second part is different. Instead of stubbing the method, we mock it. That is, we set expectations on its behavior. We expect the collaborating method parse CSV line be called exactly twice. Now, our primary method requires a database object. For this, we'll use a dummy. In PHPUnit, when you create a mock without any extra settings, it basically creates a dummy. All of its methods will be stubs, so no real database writing will occur. Our primary method also requires a path to a CSV file. Here we have a simple CSV file with 2 lines in it. Next, we exercise the method by calling it with the file path and our dummy database. And finally, we ensure the 2 records have been returned. Notice that we don't check for the content of the records, as that has already been established in the previous test. Plus, we won't be getting any real records since the real parse CSV line doesn't get called. There's another implicit verification here that happens at the end of the test. PHPUnit will verify the expectations we set earlier. So if we change the expectation to 1 call, PHPUnit will tell us was not expected to be called more than once. We'll test import from CSV again. This time though, we will verify that save records has been called the correct number of times and that the right parameters were passed to it. This will be achieved by using a spy. It will eavesdrop on the calls to that method and collect all the information about those calls. This is where the name spy comes from. In this test, we want to check that save records is called with the correct parameters. The setup here merely serves to isolate the primary method from its internal collaborators. The database dummy is still needed to avoid creating real records, but this dummy will also help us set up the spy. We expect any number of calls on the method save records. In the expectation, this any actually returns a spy. It will collect data about all our calls to this method. We set up the path and exercise the method. This is where it gets interesting. The spy can return a list of invocations, which is the list of all calls made to the save records method. We can then assert that the method was called exactly once, similar to what we did with the mock, but it goes a little deeper. We can also grab the first parameter from the first invocation, then assert that an array was passed to the save records method. We can also assert that the first item in that array is an object of type call. So if the primary method decides to save any other type of object to the database, the test will fail. Pretty cool. A fake provides your test with an alternate working implementation of a method. It is meant to take shortcuts, which is particularly suitable for quickly creating prototypes, speeding up tests, and testing various edge cases. For example, an in-memory database is a fake. You won't use it in the real system, but you will in the tests. Fakes are mostly used in integration and system tests. Unit tests are usually controlled enough that you can get away with the other 4 types. In the example, I'll use it in the context of a unit test for the sake of simplicity. We're testing the import from CSV method again. We want to check that it reacts correctly to invalid customers, but this time using a fake instead of a stub. Let's isolate the primary method again. For the method isExistingCustomer, instead of returning a fixed value, this one will return a callback method with a real working implementation, just not one that hits the database to see if the customer is there. In the previous example, the stub method didn't care which customer ID you provided. The fake method does. If a customer ID of 999 or greater is provided, return false. Otherwise, return true. We set up the CSV with a custom ID of 1000 and exercise the method. This should throw an exception. I find that creating a fake is particularly useful for external APIs. Knowing what each type is called is not critical to your testing, and you will eventually develop an instinct as to which type to use where. Also remember that if you have too many mocks, then you're either using the wrong type or you have too many collaborators per primary method. In that case, try to simplify your design by reducing the length of your methods and by limiting the number of collaborators that each method has. Alright, that's it for this video. Don't forget to hit like and subscribe to my channel. Check out my upcoming workshop on automated testing in the description below. The code is available on GitHub for you to explore. And as always, please support me on Patreon to help me create even more great videos. Thank you for watching and happy coding!